So now these are the waves we've discussed before, correct? What were the two waves that we saw? Longitudinal and transverse. Longitudinal waves are waves that in which the medium moves along the direction of the wave. Transverse waves are waves in which the medium actually moves up and down. So remember I said that when the wave moves, it moves with a different speed. Now let's write the formulas for, well, that is missing something. It should be rho underneath. I don't know why that didn't show up. So the formulas are going to be different when you're talking about longitudinal waves and transverse waves. So for our longitudinal waves, the formula for the speed is E over rho. Now, in our class, we don't have to actually worry about the Young's modulus, the what is called E. Sometimes it's also written as Y. In some textbooks, you'll see it written as Y. It's the same thing. So we don't have to worry about where that came from. I will give you the values of that. The only thing you have to worry about is the density. Yes. No, that is just or. Like you'll see it in sometimes textbooks write it as E and sometimes they'll write it as Y. Oh, yes. Thank you. I don't know why PowerPoint is messing it up. Thank you. Yes. It should be V equals square root of E over rho. So if the question asks you to find the speed of sound in a thin rod made of this alloy, and it's giving you a Young's modulus and a density, use the formula E over rho, square root. Plug the numbers in, Pascal, divided by density, which is 8920 kilograms per meter cubed, and then square root it. And that will give you a value. And your answer will come out to be in meters per second. Now, I think the homework gives you density, but it gives you density in like grams per centimeter cubed. So you will have to convert it to kilograms per meter cubed. So 1 kilogram equals 1,000 grams, and 1 meter equals 100 centimeters. And there's, since this is cubed, how many times is this? Centimeter? Centimeters, centimeters, centimeters. This is 3 times. What's a what? Oh, Pascal. It's a unit of pressure. So these are all pressure waves, right? Because longitudinal waves are pressure waves, and the unit of pressure is Pascal. Okay, so anyone come up with an answer for this? Yes? What?
3,511.
For transverse wave, the speed is given by T over mu. And I know we haven't defined mu. All it is mass per unit length, where T is a tension. We've talked about tension, right? Tension is how much the string is being stretched. And mu is just the mass of the string divided by the length of the string. Write this formula down as well. And why do we use mass per unit length? The reason why we use mass per unit length is because we don't want to worry about the length of the string if it's like a kilometer long, right? We only want to worry about just the part we're looking at. So if mass is given in the question and length is given in the question, make sure to just do M over L to find mu. And then plug that value in here and you're done.